Hi, Assalamualaikum. My name is Syed Ahmad Akil Nuri bin Syed Zainal Abidin. I from Johor Bahru.
My name is Umar Taufik bin Manizam. I'm from Kajang, Selangor.
My name is Muhammad Nur Ammar bin Yusuf and I'm also from Johor Bahru.
And today we're going to explain about differentiation.
Is Umar Taufik, and I will be introducing you to differentiation. So the definition of differentiation is the process of finding the instantaneous rate of change of a function with respect to one of its variables, which is equivalent to finding the gradient of a curve at any given point. It's a core concept in calculus used to determine things like velocity from a position function or to find the maximum and minimum values of a function. So there is 6 method of techniques of differentiation, which is constant, power, polynomial, sum and difference rule, product rule, and quotient rule. Number one is constant. If a function is just a constant, its derivative is 0. So for example, if fx equals to 7, if we differentiate this, it will just be 0. And number 2 is power. If the function is x and n is a constant, we have to multiply this n with x and minus the n with 0. So for example, if x equals to 5, we multiply 5 with x, and then we minus 5 with 1, and we will get this. Is polynomial. Polynomial is similar to number 2, which is power, but in the power, there is only one term. In polynomial, there is a bunch of different terms in one function. So polynomial is differentiate term by term using power rule, which is number 2. So if we differentiate 3x to the power of 4, we will get 12 x equals to the power of 3. And if we differentiate negative 5x to the power of 2, we will get negative 10x. And then plus 7x differentiated is plus 7, and negative 9 is 0. So for number 4, sum and difference rule, we have equation, which is this. So basically, sum and difference rule is you can differentiate addition and subtraction separately. So if we have y equals to, or fx equals to 3x to the power of 2 plus 5x, we can differentiate these two terms separately. So 3x to the power of 2 is u, and 5x is v. So we can differentiate 3x to the power of 2, which is 6x, plus 5x, which is 5. And then y derivative is 6x plus 5. Product rule. So product rule is used when there is a term multiplied with another term, like for example, like this. And we can use this formula, which is derivative of y equals to u prime times v plus u times v prime. So x to the power of 2 is u, and sin x equals to v. And then we can implement this formula into this function. X to the power of 2 is u, and sin x is v. And we, u prime is x to the power of 2. We can differentiate this, and it will become 2x. And then v is sin x, so we just take this and write down, plus u, which is x to the power of 2, and write down here. And then sin v prime is sin x, differentiate, we got cos x. And the final answer will be like this. Number 6 is quotient rule. Y prime quotient rule is we can use this when one function is divided by another. So the formula is derivative of y equals to u prime, same like product rule, but we will divide this with v to the power of 2. So example of this is x to the power of 2 over x plus 1. So u is x to the power of 2 is u, and v is x plus 1. So we can just implement this using this formula. U prime is x to the power of 2, differentiate, and then v is x plus 1, like this, minus u. U is x to the power of 2, and then v prime is x plus 1, and differentiate them, we got only 1. And then we get this function 2x to the power of 2, which is 2x times x, and then 2x times 1 is 2x plus 2x, and then negative x minus x to the power of 2 times 1 is negative x to the power of 2. And then we will get v to the power of 2. We can just simply write it down, v, which is x plus 1, and then we'll get the final answer of this.
Today, I want to share with you guys how I solve this question. To differentiate this equation, we need to use product rule. Okay, step 1 for product rule, you need to label. I label the 3x squared with u and sine 2x with v. So after you label this, you need to differentiate these two variables. When you need to differentiate this variable 3x squared, you need to use power rule. So you will get 6x. How I can get it? With 2, you need to move in front, and power, this 2, you need to minus 1. You will get 6x. And differentiate sine 2x. Differentiate sine 2x, I will get this cos 2x times 2. Step 2, you can use the product rule, which is dy over dx equal to u v prime plus v u prime. And you need to substitute the value of this variable u 3x squared v prime cos 2x times 2 v sine 2x u prime 6x. Simplify the equation. 3x squared times 2 6x squared cos 2x plus 6x sine 2x. Okay, that's all. Okay, next question. The question said use chain rule to differentiate y equal to sine x cubed minus 2x squared plus 1. Okay, what is chain rule? Chain rule formula is dy over dx equal to dy over du times du over dx. Okay, step 1 for chain rule, same like before, you need to label it. Okay, let's say I label the equation in the bracket as u. So u equal to 3x cubed minus 2x squared plus 1. And y equal to sine u. After you label, you need to differentiate these two variables. When you differentiate u, you will get du over dx equal to 3x squared minus 4x. You differentiate this, same you do as usual. And when you differentiate y, you will get cos u. Next, after you finish the differentiate, you can use the chain rule formula, which is dy over dx equal to dy over du times du over dx. So after that, you need to substitute the value of the variable of this. So dy over du equal to 3x squared minus 4x. Mistake. Okay, dy over du is cos u, and du over dx 3x squared minus 4x. And then you need to substitute this value, which is this cos 3x cubed minus 2x squared plus 1 in the bracket times 3x squared minus 4x in the bracket. And then you need to rearrange the equation. 3x squared minus 4x in the bracket cos x cubed minus 2x squared plus 1. Okay, that's all. Last question. Given exponent power of 2x plus 1 minus x squared tan 2y plus ln xy equal to 0. Find dy over dx by using implicit differentiation. Okay. First step, you need to differentiate each term like this. D over dx in the bracket exponent 2x plus 1 minus x squared tan 2y plus ln xy equal to dx 0. D over dx 0. After that, you need to differentiate all this in the bracket. Differentiate e exponent, you will get 2 exponent power of 2x plus 1. Differentiate x squared tan 2y, you need to use product rule, which is you need to label it first. U equal to x squared. After that, you need to differentiate these two variables. Differentiate u, you will get 2x. Differentiate v, you will get differentiate tan secant square 2y times 2 dy over dx, where I get this with differentiate in the bracket. After that, substitute into the formula product rule. U v prime x square times secant square 2y 2 dy over dx. You need to rearrange back. 2x square secant square 2y dy over dx plus 2x tan 2y. After that, you need to differentiate ln xy. Differentiate ln 1 over xy. And you need to differentiate this variable in the bracket, which is you need to use product rule. Same as usual. U equal to x, v equal to y. So you need to differentiate it. X, differentiate x, you will get 1. Differentiate y, you will get dy over dx. Okay, so substitute to the formula. You will get x times dy over dx plus y times 1. Okay, so differentiate ln xy, you will get 1 over xy times x dy dx plus y. So after that, you need to substitute back into the equation. You will get this. After that, next step, you need to factorize the dy dx like this, which is dy dx, you move to this left side, and another you need to move the other side. After that, you need to solve and simplify the dy dx. So let's finish it. X to x squared and 2y minus 2x exponent 2x plus 1 minus 1 over x divided by 1 plus 2y x squared secant square 2y over y. So dy over dx equal to y 2x squared and 2y minus 2x exponent power of 2x plus 1 minus 1 divided by x 1 plus 2y x squared secant square times 2y. This is the final answer.
Hi, my name is Ammar, and I'm going to show you how to use linear approximation to estimate value. The value is square root 15.98 over 3 minus square root for 15.98. As for the 15.98, we use it as the x. Then we use linear approximation nearest to the x, which is 16. 16 as the a. Then we substitute the 15.98 to x. After that, we use the differentiate. S power of 1 over 2 over 3 minus S power of 1 over 4. And then we differentiate it as the I use then we got ourselves a f prime 1 over 2 1 over 6 x power of negative 1 over 2 minus 1 over 4 x power of 3 over 4 negative. Then we use the formula ls equal to fa plus f prime a s minus a. Then we substitute it from the answer that we got. For the fa, we use the fx, which is square root s over 3 minus square root 4 over s plus, from the fa we use the 1 over 6 s power of negative 1 over 2 minus 1 over 4 s power of negative 3 over 4. For s and a, 15.98 minus 16. Then we substitute the s for s. We substitute the s for 16. Plus 1 over 6 times 16 negative power of negative 1 over 2 minus 1 over 4 times 16 power of negative 3.4, then 0, negative 0.02. 2 over 3, then we got 2 over 3 plus 1 over 69 times negative 0.02. Then we calculate it, we got 0.667, negative 0.667.